On a warm September morning in 1994, a ribbon was cut, cameras flashed, and the world held its breath. Somewhere in the middle of Osaka Bay, Japan, sitting in roughly 18 meters of water, a brand new international airport opened for business. It shouldn't have been possible. The engineers who first proposed it were told they were dreaming. The geologists who studied the seabed warned of catastrophic sinking. The economists who ran the numbers called it financial madness. The fishermen whose livelihoods depended on those waters launched protests that lasted years. And yet, it was built. This is the story of stubbornness, genius, political will, and the very Japanese belief that no obstacle is truly immovable. By the 1960s, the Kansai region was booming. Osaka had emerged as one of Asia's great industrial powerhouses. The region's existing airport, Itami, was straining at every seam. Itami Airport had one fundamental, incurable problem. It was surrounded by people, millions of them. Every takeoff and landing sent jet noise cascading over hundreds of thousands of homes. Lawsuits piled up, noise curfews were imposed. Between 9 p.m. and 7 a.m., no flights were permitted at all. An international airport that couldn't accept long-haul flights at night was, to put it plainly, not doing its job. Mountains hemmed in the region from the north and east. Urban sprawl made any inland location politically toxic. And yet, the offshore option kept coming back to the table because it was away from people. An airport built on an artificial island could operate 24 hours a day, 365 days a year. No curfews, no complaints. In 1974, the government made its decision. The first engineering surveys of Osaka Bay delivered deeply alarming news. The seafloor was not solid rock, not firm sand. It was soft, highly compressible Holocene clay, the kind that behaves less like solid ground and more like very thick pudding. Beneath that Holocene clay was another layer of even older Pleistocene deposits, extending down hundreds of meters. Early estimates suggested the island could sink by as much as 8 to 11 meters over its operational life. Not millimeters, not centimeters, meters, plural. The very idea of building an airport on this seafloor seemed to many engineers fundamentally insane. But the Japanese engineers did something remarkable. Instead of asking, "Can we build here?" they asked, "How do we build here?" The first step was ground improvement, using vertical drains, thin plastic strips inserted deep into the clay to accelerate the squeezing of water outward. It was a strategy of controlled, accelerated defeat. Make the ground sink as fast as possible before the permanent structures are built. They designed everything, the terminal, the runways, the seawalls, to be adjustable. Construction of the artificial island began in January 1987. The island's footprint, approximately 4 kilometers long and 1.25 kilometers wide, covering 511 hectares, roughly 1,260 acres. Every cubic meter of that gain had to come from somewhere. The answer was mountains, literally. 3 mountains, Ikoma, Roko, and Izumi, were partially excavated to provide 180 million cubic meters of earth and rock. Conveyor belts carried the material to waiting ships at the waterfront. A fleet of 80 specially designed vessels worked around the clock, making roughly 60,000 trips over the construction period. Ships would position themselves over the designated fill zone, open their bottom dump doors, and release their load. First came the seawall. 22 kilometers of it, made from enormous hollow concrete caissons, each up to 70 meters long. Each section had to withstand the full force of typhoons, tsunamis, and the everyday working of the sea. The operation ran for years, through typhoons, through extreme heat, through political protests. By the early 1990s, the island was visible. From a distance, it looked almost unremarkable, a flat brown rectangle sitting in the blue waters of the bay. Up close, it was one of the greatest earthworks in human history. In 1988, the Kansai Airport Company held an international design competition for the terminal building. The winning design came from Italian architect Renzo Piano. Piano proposed a single terminal building, one of the largest in the world, whose defining feature was its roof. A sweeping, wave-like structure of thousands of stainless steel panels inspired by the wing of a glider. The building would be 1.7 kilometers long, longer than 16 soccer fields placed end-to-end. Passengers moving through it would have the sensation of being inside something immense and organic. Piano's curved roof was designed to work with the physics of air movement rather than against it. The double-curved surface could not be constructed from standard rectangular panels. Every single panel is slightly different. Arups engineers wrote custom software to calculate the exact dimensions of every one of the thousands of panels. Because the island was still settling, the building had to be built with the expectation that the ground beneath it would move. The solution was a forest of steel columns, each equipped with adjustable jacks at its base. Every joint, every pipe connection, every electrical conduit had to be flexible enough to accommodate movement without cracking, leaking, or failing. When it opened in September 1994, the architectural world was stunned. Piano's creation won the Aga Khan Award for Architecture. It helped earn him the Pritzker Prize in 1998. The original budget, approximately 1 trillion Japanese yen, roughly $7 to $8 billion. By the time the airport opened in 1994, the cost had climbed to 1.5 trillion yen. By the time Phase 2 completed in 2007, roughly $20 billion, one of the most expensive infrastructure projects in human history. The cost overruns came from every direction simultaneously. The airport's landing fees became among the most expensive in the world, a competitive disadvantage airlines couldn't ignore. For years after opening, the airport struggled financially, revenues insufficient to service its debt. It took decades of patient restructuring before the airport reached sustainable operation. The settlement crisis was almost existential. In the first years after opening, the island was sinking at approximately 50 centimeters per year. By the mid-2000s, the island had sunk approximately 8 meters from its original constructed height. Managing this sinking has required continuous, active intervention for over 30 years. The seawalls have been raised in sections where freeboard threatened to become inadequate. The remarkable thing, the thing that testifies to the genius of the original engineering, is that it has worked. In September 2018, Typhoon Jebi, the most powerful to strike Japan in 25 years, made landfall. Winds exceeded 215 kilometers per hour. The storm's path took it directly over Osaka Bay. A tanker, torn from its moorings, drifted on the current and collided with the airport's access bridge. Some 3,000 passengers and workers were stranded on the island, cut off from the mainland. And then look at what didn't happen. The 22-kilometer seawall took the full fury of Jebi's storm surge and did not fail. The runways, once the floodwaters receded, were found to be essentially undamaged. The airport partially reopened within days, fully operational within 2 weeks. Typhoon Jebi was paradoxically a vindication of the airport's design. The Skygate Bridge R, 3.75 kilometers across open water, carrying both road and rail on 2 stacked decks. Road and rail had to coexist. The most efficient solution: stack them. The island end of the bridge sits on settling ground. The mainland end does not. Building across that differential required solutions never attempted at this scale. The slight upward bow visible in the bridge profile was partially deliberate, an anticipation of the sinking that would flatten it over decades. Today, approximately 18,000 vehicles per day and hundreds of trains. Passengers reach the island from central Osaka in 30 minutes. Planning for a second runway began almost before the first one opened. Rather than expand the first island, engineers proposed building an entirely new one beside it. The second island, 545 hectares, 1 additional runway, built with the hard-won lessons of Phase 1. When Phase 2 opened in 2007, Kansai became a 2-runway airport with a total island area of 1,056 hectares. Before Kansai, no one had built a major airport on a man-made island in deep water on highly compressible soil. After Kansai, they did. Hong Kong's Cheklap Kok Airport, which opened in 1998 on its own man-made island, drew heavily on the lessons of Kansai. Kansai's most important legacy may be philosophical rather than technical. It declared, "Obstacles are not limits. The sea is not a boundary. When a nation decides something must be done, it can be done." On any given day, Kansai handles flights to more than 190 international destinations. It is the primary gateway for 20 million people to the temples of Kyoto, the street food of Osaka, the castles of Himeji. The sinking continues, quietly, imperceptibly, day by day and year by year. Maintenance crews continue their patient work, adjusting jacks, re-leveling surfaces, monitoring the seawall. Engineers believe the settlement will continue for centuries, long past any human horizon of planning. There is a Japanese phrase, gambaru, to persist in the face of difficulty, to endure, to refuse the easier path. Kansai International Airport is gambaru made physical. $20 billion of national will poured into the sea and told to stay there. Japan built an airport in the middle of the sea. It cost too much, it took too long, it sank more than predicted, a typhoon flooded it, and it works. Every day, it works. The argument is the daily ordinary miracle of planes landing and taking off from a rectangle of earth that human beings placed in the water and told to hold. It holds.